word what code or coding is? What do the software developers even do when you order a piece of software from them? And how do those characters that we type with a keyboard become an actual working solution? Or perhaps you've thought about becoming a programmer yourself. All of those are questions that I aim to shed some light on during these next 30 minutes, because software is already everywhere and it just becomes more important all the time to understand their working principles. Coding is sort of a superpower that everyone can learn to automate some tedious and time-consuming tasks. And even if programming doesn't seem like a very relevant thing for you to do, it's still important that you understand the basics of how software tends to work, how it's built. My name is Kokkarinen. Feel free to also call me Laura if that's easier for you. I currently work as a senior developer and a solution architect at Highlevel, which is a company in Finland fully focused on Microsoft Cloud. And I'm personally currently the most focused on Office 365 development, like what kind of customizations we can do for that. But I also develop for Azure because that's very tightly connected to software development for Office 365. Personally, I started coding when I was 18 years old because that's what I realized what I wanted to do for a living. When I was graduating from upper secondary school, I had to think like, what am I going to do with my life? And I figured that if I could make one of my hobbies into a profession, I would probably have a lot of fun going to work every day. And my options were basically dancing, visual arts, and computers. Because I've always been interested in computer games ever since I was like 4 years old. And I thought that, well, I should have better chances of getting a good paying job if I wanted to become a game developer rather than a dancer or an artist. So I started studying computer science, and that's where I learned. I know some people started like when they were 8, 12, whatever, but really there's no age limit to when you can start programming. Everyone's life is different. So yeah, I went to study computer science, got my first job, summer job when it was 2010, and then I got involved with SharePoint on 2011. So it's almost been 10 years that I've been working as a software developer full-time. Anyway, let's go to the actual topic. What I have here for you is a coffee brewing algorithm written with pseudocode. An algorithm means instructions for performing a certain task, like to the computer. You tell the computer, do this and this and this and this and this, and then you get an end result. And pseudocode is like this imaginary programming language that the computer doesn't need to understand. It's basically for us humans to quickly illustrate the logic that we could later use for actually solving the problem. So it's more important that you understand your imaginary programming language, and maybe it's clear so that you can explain it also to someone else. So how do we teach a computer or a robot? Let's think about a robot this time. How do we teach a robot to brew us some coffee? So let's say that we want 5 cups of coffee, and for that we have this brew coffee method. And for that we give a parameter 5 because that's the amount of cups that we want to make. And then we have this method or a function which we basically call here, and we give it the parameter number of cups. And what we need to instruct the robot to do first, if we're making, this kind of filtered coffee, is to insert the coffee filter into the coffee machine. That could be another method. Then measure the coffee grounds into the filter, and there we need the information of how many cups of coffee we want to make. And then after that, we pour hot water over the coffee grounds. And again, we need to measure the right amount of water so we get the correct strength of coffee. So you see that we are already splitting the large task of brewing coffee into smaller tasks. And we can then make these tasks even smaller. So if we take a look at what this measure coffee grounds into the filter method could contain. So there we are getting the number of cups again, which is 5. And then we check, do we actually have enough coffee in the house for making the amount of cups that we want to make? So do we have at least as much or more coffee? And if we do, then we add the grounds into the filter. But if we don't, then we go grocery shopping. So this is what code is, essentially. It's this kind of instructions, what kind of steps you need to do, and then different kinds of checks, for example, that can we actually perform a certain task. And then there can be structures like loops, which make you do the same thing all over and over again until a certain rule is fulfilled. So how does the computer understand us? As I mentioned earlier with that pseudocode, computer doesn't understand that because it needs a certain kind of syntax. And if we just imagine a language, then how could the computer understand that? That's why we actually have high-level programming languages that have certain way of describing those steps. So when you start planning your software, you can use pseudocode for quickly sketching what the logic could be like, and then after that you write that same logic in a high-level programming language. These are made so that it is still quite easy for us humans to understand the instructions and write them ourselves fairly effectively. But even though the computer will eventually be able to understand the real high-level programming languages or the instructions that we've written with them, it doesn't understand them directly. There's something else going on. When we first write the code in a high-level programming language that is easy for us to write, easy for us to read, then there is an application called a compiler or an interpreter that basically translates the high-level programming language into machine code that the computer can understand. But you probably realized, hold on, computer is an electric machine. How can it understand zeros and ones? It doesn't. It understands voltage. And when we first write code in high-level programming language, then this compiler will translate that code into machine language, binaries. Then the computer processor can take a chunk of those zeros and ones, and it gets a certain voltage out of that, and then the processor does something based on the voltage. But luckily, as a programmer, you don't need to understand and keep in mind all of this. This was more like good to know what's going on underneath. What you actually need is the high-level programming languages. And then you need to know that, well, you need to build the code before you run it. So what high-level programming languages are there? There are dozens of programming languages, and here I've gathered some of them that seem to be popular these days. Personally, I've used Java in the past. It was actually the first programming language that I learned. But these days I write most of my code with C# and JavaScript, or TypeScript, which is the typed version of JavaScript. I've tried C++ on a university course and done a little bit of Python at some point. So what I'm trying to say here is that you don't need to learn all of these. These languages are basically for different purposes. So first think, what do you want to achieve? And then check which languages allow you to do what you want to achieve. Then on the right side I have some languages which, depending on who do you ask, are not really classified as programming languages exactly. But to make things simple for this, let's just say that they all are, because they all have a syntax and they are used in automation. So HTML is this markup language that you can use to create the kind of structures that you see on web pages. So it is the only this kind of language that you can use for creating browser-based user interfaces. Like what kind of elements go where? Do we have a table somewhere? Is there a box? Is there a piece of text? Is there a hyperlink? Is there an image? All of those are things that you can do with HTML. And then CSS is a styling language, cascading style sheets. And without it, the HTML that you write would look really ugly. It would just be black and white with blue links that turn purple when you click on them. And JavaScript, which was already on the left side, that's how we bring automation to the websites. Then JSON and XML are these data formats that are used for transferring messages often, so that computer code can easily read data from that format. And then we have SQL, which is a database language, structured query language. You can do database operations with it. And then I've included a PowerShell icon in here because a lot of people might be, who are watching this, might be familiar with PowerShell. But in fact, did you know that a lot of PowerShell modules are actually written in C#? So it's basically just a bunch of code put into those commandlets that you can just run like that. Now let me show you an example of a website architecture. I already briefly mentioned that we have those three things for building user interfaces. So we have HTML for the structure, CSS for the styles, and JavaScript for the automation. Like, for example, when a user clicks a button, what happens? We can't necessarily do everything in the user interface, so we might need this kind of a server-side backend level, that some things are not executed in the user's browser, but instead on a server. It could be a performance reason or a security reason. And communication between the user's browser and the server happens by using the Hypertext Transfer Protocol, HTTP. And I already mentioned JSON, that is, it's this format that the computer can easily read, that it contains data in a text format. We use that in the HTTP request body for transferring information from the browser to the server and back. So those two levels in different places communicate like that. And then we might have a database as well for storing all the information that the user sees and submits. And our user interface doesn't directly communicate with the database. That would be very insecure, and that's why we need the server side in between. And you might notice these two icons here that I haven't explained to you yet. In addition to just focusing on learning languages, you might at some point want to learn to use some libraries or code frameworks. Here, for example, I have an icon for the React JavaScript library, and here I have an icon for .NET Core framework. And what the libraries and frameworks do, they basically make the whole programming process a lot faster, because they offer you commonly used code that you can just take advantage of, and you don't need to reinvent the wheel every single time by yourself. But it also takes a little bit of time to actually see how they work and what's available. So you need to spend a little bit of effort on those. Then I actually have a demo for you. It is a solution that I built for Office 365. It has a SharePoint framework user interface, something that you can include in SharePoint Online or Teams. Then it has a backend that I've hosted in Azure, and then it also has a Power Automate flow. So here's my test site, and here is the solution that I want to show you. So it's basically a web part, browse and join teams, and this drop down lists all the teams that the logged in user is not a member of. Teams by default does not offer this kind of view. You can only search for teams, or then teams might recommend some team for you, but you pretty much need to know what the team is called if you want to find it. So what if I click on this marketing? It opens this kind of card with information. So there's a title, there's a team description, who are the owners, and then there are some icons indicating some things like this is a private team. It is currently marked as not discoverable. I have this kind of admin mode on in this web part, so it also lists these not discoverable teams, but you can also in the settings make it so that it doesn't list this, but then I wouldn't have a lot to demo here. Then there could be an icon for if the team had guests. This one doesn't, so it doesn't show. And also there could be an icon if the team was archived. And then there's a button, because this is a private team, there's a request access button, but if it was a public team, then it would have a join button and I would be able to join it immediately. But then I also have a backend, which first of all gets the teams for this list, because some organizations might have a lot of teams. So I want to do server-side caching of the all teams pool, and then do comparison of which one of those teams the user already belongs to, and then return only the rest to be rendered in this dropdown, because it's such a time-consuming task that the user would otherwise need to wait for a really long time here. And then also this request access and also the join request gets sent to the server side to be processed. But let me show you first how did I build this user interface, or at least some of the code. Here you can see some of HTML markup, these div tags, but I'm actually using a React JavaScript library here. So That's why these properties look a little bit different. If it was plain HTML, then it would just say class. But I wanted to use the React because it makes developing these user interfaces just so much faster. Basically, here I have this big div tag is the whole container, and inside that I have first the title of the web part, which was browse and join teams. After that, I render a drop-down of all the teams, and if the user was already a member of all teams in the tenant, then I would render this kind of text that you're a member in all teams already. And the callout code is described here, so we have a card control there, which contains text such as the team display name, the team description, who were the team owners, and it renders this kind of personal cards in there like this. There would be a profile picture if they had profile pictures, but at the moment it just shows default one and the username. And then we have the icons on the right, so we show either a log for a private team or a globe for a public team. This kind of people alert icon if the team has guests, repo icon if the team is archived, and this kind of eye with a crossover if the team is not discoverable. So this section is basically this one here on the right. That's how you can create user interfaces for browser-based solutions. So what happens if a user clicks on this request access button? Then a request gets sent to the server side, and I have the server side code here. So it executes this kind of HTTP put type of method. So it sends the HTTP request from the user's browser to the server, tells what the team ID is, and the user ID in the request body. Why do we use IDs? Is because they are unique, so we can't confuse them with someone else. For example, we might have several users with the same name, so IDs are always used, that's why. Identifiers. To add the user to the team or to initiate the access request approval process, we call this execute join request method, which I have here, and that will check for the group visibility again on the server side for security reasons. And then if it's private, it starts the approval flow, and if it's a public team, then it just adds the member to the team. And what does the approval flow look like? So basically my server-side code sends the information, so team ID and user ID, to this URL address. And with the team ID, we get the owners of the team, the people who will be approving the request. And with the user ID, we get more information about the user who wants to join the team, just so we can tell a little bit more about them to the approvers than just the user ID, which doesn't tell much to a human before they actually look who is it connected to. We've gathered the owner emails into a variable, and in this approval request card, we present the user's display name and email address and the team name to the approvers. Then we have this action that allows us to send the approval card generated by the create approval action to each one of the approvers that we set over here, so the owner emails. And then we stop to wait for an approval. When any one of the approvers replies, we want to send to the other approvers a summary about the approval that has already occurred, so they realize that they don't have to participate in the approval anymore. So we loop through the approvers and check that the person that we are iterating is not the same one who approved, and if that's the case, then we send them the summary. And based on the outcome, if it was approved, then we add finally the user who requested access to the team. And in Teams, the approvals look like this. So at first you get this kind of card, so the person who requests access, the team name, you can approve and add some comments if you like. And then if someone gets there before you, then this is what the summary looks like. So we've seen that Albert has approved this request and said that this is okay. Very useful comment. Okay, so now you've seen an example of a solution you could build. But what are the exact steps that you need to take on your journey of building that kind of application from start to finish? What kind of things does software development actually involve? First, and the most important step is careful designing and planning. Because if a mistake is made at this step, then fixing that mistake gets more and more expensive the further the project proceeds. It's very important that you carefully discuss, or if not you personally, then the architect of the project, discusses with the customer what are the exact requirements for the software, so you're actually creating something that the customer wants to use. If there are some issues that arise during a software development project, they usually initiate from the design phase. So someone forgot to tell something to the other party, they figured that surely they already know this, I don't need to mention it. Or then the developer or architect thought that, I'm sure the thing that the customer wants is this, I don't need to ask this. They make assumptions. It is better that you communicate too much than just enough to get by. Then after the planning phase, we have a phase that is often dreaded by software developers and architects, and it is giving the work estimate for the solution that we have just finished designing and planning. And quite often customers ask you to give some kind of a quick work estimate out of your sleeve already during the designing meeting, but I don't recommend you do that because it gives them possible false expectations even if you were to correct it later on. I recommend that you always sit down and think through the plan properly. What are the exact steps you need to take? Give them work estimates, sum them up, and that gives in total a lot more realistic work estimation. Because none of us have crystal balls. I'm not an oracle, you're probably not either, who knows? So we can't really see the future for sure. We can only give our best guess, and that's what a work estimate is, an estimate. But I also understand that customers want this estimate because they need to ask for money from the organization for this project, and they use the work estimate for that purpose. And then they have that exact amount of money at their disposal, and that's why it's such an obnoxious conversation to have with a customer if the budget goes over, because they don't necessarily have the extra money and they need to ask for more. So yeah, that's why it's also good to have a little bit of buffer in the work estimate rather than be too positive about it. We humans tend to be quite optimistic about work estimates, so always try to think about the worst case scenario. Sure, it can be quite difficult though, especially if you're in a competing situation with another supplier and you have to think, what if they give a really small work estimation and that's why we lose, even though we have prepared for everything. It's challenging. Then after giving the work estimation, the customer reviews it and hopefully also approves it. And at that you actually get to work. So this is what coding looks like. Here I am creating a SPFX extension for a customer who wanted to print list item properties with a certain layout. And what I'm basically designing on paper there is the layout of the user interface, and then I'm using the command prompt for running some commands to generate my project structure. And while that's running, I'm also checking the user voice to ensure that there's no feature similar to what I'm about to create coming out in the near future, because we don't want to reinvent the wheel if something's already available out of the box. And after that, I'm researching on some options that I might have for printing the user interface while I'm using the React JavaScript library. And I found a package called React to Print, if I remember correctly. And then I remember that it was actually used in one open source sample on GitHub, so I decided to check how the other programmer has used it, and then I made some additional changes to my plan. How am I going to adjust the controls and so. And there I was already starting to code and immediately test that my extension base loads up correctly as I want. And then I proceed to create the icon that I want to display for the extension button in the list. So it's not just about coding our work, we do a lot of different kinds of things. There's a lot of research involved, a lot of checking different kinds of materials, and even sometimes graphic design, if you want to do that yourself. There I was checking how to make the icon background transparent with GIMP. Yes, we need instructions for that. So here I've listed some things that we do in software development and programming. Most of all, it's logical thinking and problem solving, how you're going to implement something that a customer wants. And for that, you need to do the research, the study, the investigation. And investigation is also sometimes related to troubleshooting when there is some kind of problem. It's also focusing on the details, because without the details, there's just not enough precision to the execution of the different tasks. And you also need to be able to predict behaviors, both human behaviors and behaviors by the technology that you're using. For example, what if a user mistypes an email address? What do we do then? We probably need some kind of validation. And we also need to think what kind of program functionality is as intuitive as possible for the end users, so they don't need to read through a thick instructions manual every time they want to use our software. For example, what I was doing with GIMP earlier when I was trying to make that icon background transparent. I can never remember how that's done, so I need to Google up the instructions every single time. And software development also includes customer service. A lot of people might think that all you do is sit by the PC and just smash your keyboard and stare at the code editor, but that's not it. We actually need to discuss with the customer quite a bit to ensure that we are creating what exactly they want. Software development is also creative building, especially in the design phase, because you have a lot of different kinds of building blocks. You can create the same thing in many different ways, so you sort of have to think what is the best possible kind of implementation for this customer and their needs. And then you get to pick the best tools for the job. That's very satisfying in my opinion. Now here's a GIF that I spotted on Twitter about how the programming languages and their popularity has changed over time. As you can see, there's a lot of languages listed at the moment which are not that popular anymore. So why do we have different languages that are popular today than those languages that were popular before? Well, we learn to do new things all the time. We learn to do all things more effectively, and that's like the beauty of modern programming languages. We can do the same things we've always been doing, but a lot quicker than before. This can also be a comforting thing to understand as a new programmer, that you don't need to learn all the old stuff that the senior programmer has already learned during their career. You can sort of pick up the currently popular languages and frameworks and learn those and get to work. Of course, there are benefits to having a lot of experience. First of all, learning new technologies and languages gets a lot easier because you realize that the same working principles are pretty much everywhere. So you can base new knowledge on top of old knowledge. That, okay, this works in a similar way as that other thing that I was doing previously. And also, when you have gained a lot of comprehensive and broad experience, you're able to do architecture design as well. Okay, we're closing to the end. How are you feeling? Did you get excited about programming? Did those questions that you have get answered? Now, if you want to start coding and don't necessarily want to go to school, you could, for example, check the precodecamp.org. I heard that that's a pretty good resource. I haven't checked that myself. And then another thing that you might want to check is whether your local universities have these massive open online courses that you could join and take. For example, the University of Helsinki has one of these which don't have any schedule. You can just jump in whenever you want. It's totally free, and if you then later on decide to go study computer science, they can give you some student points for those courses that you already taken, so you don't have to take them again. Definitely check your local universities for similar things. If you have any questions, please write them down and I will reply to them a bit later. Thank you for watching and I'll see you around. Bye-bye.
Thank you for being a part of the Galactic Collaboration Summit. Join the community and meet in-person world-class Microsoft and MVP speakers this autumn in Wiesbaden, Frankfurt, Germany, with 15 full-day tutorials and over 150 Microsoft 365 and Azure sessions at the combined European Collaboration Summit and European Cloud Summit from 26 to 28 October 2020. Community rocks.